In this lesson, you will learn to solve problems involving direct and inverse variation. Now, as we begin, we need to define our terms. What is direct and inverse variation? Now, direct variation, by definition, is when one value increases, another value also will increase. Or as one value decreases, the other value also decreases. So for example, let's say you had a spring and you attached a weight to the spring. Well, the more weight you attach, the more the spring will stretch. Or the less weight you attach, the less the string will stretch. As the weight increases, the stretch also increases. And in physics, we call that the spring constant. Also, we can have the more hours you work, the more you get paid, assuming you get paid per hour. Or if you're driving a vehicle, the further you drive, the more gas that you will consume. So as the distance increases, the gas also increases. Now, if you were to collect some data, and the data can be anything, let's say it's y and x. And y and x vary directly, or they have a direct variation. Ways that we can say that in English would be y varies directly as x, or we can say y is directly proportional to x. Either way, we are saying the same thing. And then when you're using an equation to solve different things, and we'll explain this more in detail a little later, the equation you're going to use in this case would be y equals k times x, because y varies directly as x. So it's y equals, and then k, and then times because it's direct variation, and then the letter x. And so the constant k is what we call the constant of variation or constant of proportionality. And that tells you the relationship between x and y. So that's direct variation. The other is inverse variation, or another way to say this would be inversely proportional. Same thing. Your definition of this is the opposite of direct variation, where direct variation said as one value increases, the other value also increases. With inverse variation, or inversely proportional, as one value increases, the other value will decrease. It's doing the opposite. Or as one value decreases, the other value will increase. So for example, if you are talking about driving a vehicle, the more you drive, the less gas will be in the gas tank. So your driving increases, the amount of gas remaining in your vehicle decreases. They're doing opposite things. So there's an inverse relationship there. So in English, we can say something like y varies inversely as x, or we can say y is inversely proportional to x. They're both the same thing. And then an equation that we can use to show the relationship would be y equals k and then divided by x. So for direct variation, we are multiplying by x, or by something. And then here, if it's inversely proportional, we are dividing by something. Now, looking at the concept of direct variation, let's say we were to collect data and put this data into a table. And the question is, does the data we collect represent a direct variation or not? So let's say here is your data. And x and y can be anything. It could be maybe minutes run and calories burned, or whatever. This is data that we collect. And so to tell if this is directly proportional, or if there's a direct variation, what we want to do is we need to determine what is the relationship between each x and y value. So what I do is I take y divided by x, the second column divided by the first column. Here we have 6 over 1 equals 6. So what I have here is, if we take 1 times that 6, we're going to get 6. And then if we take 9 divided by 1.5, then we'll also get 6. So what that means is if we take 1.5 times 6, we get 9. Then notice 2 times 6 gives me 12. or I can take 12 divided by 2 to get 6. Again, same thing. Well, now because I'm multiplying each time by the same number, then we can therefore say that this is a direct variation. So it is a direct variation. The relationship between x and y is 6 times x. Y is equal to 6x. And the constant of variation is what you are multiplying by to get from x to y, which is going to be 6. This number right here that we multiply by is going to be our constant of variation. Now, for this to be directly proportional, each of these numbers need to be the same. Times 6, times 6, and then times 6. If one of these were different, then it would not be directly proportional. So here's an example where you're given the table and you need to conclude, is this a direct variation or not? Well, the question is, w times what gives me z? Or the other way around, 12 divided by 16 gives me what? Well, if I reduce 12 over 16, I can divide top and bottom by 4 to get 3/4. Do the same thing for each set of data. 18 divided by 24, divide top and bottom by 6, I get 3/4 again. One more time, 24 over 30 for the last set of numbers. Divide top and bottom by 6, I get 4/5. So notice, each time you're multiplying by something different. The first two are the same, but the third time is multiplying by 4/5. So because all three of these numbers are not the same, then this is not a direct variation. Okay, here's another example. Same thing, 5 divided by 2, 10 divided by 4, which can reduce to be 5/2, then 15 over 6, which can reduce to be 5/2. So notice each time is the same, 5/2. So therefore, yes, it is directly proportional. The relationship would be take 5/2 times s to get t, or t equals 5/2 times s. And the constant of variation would be the 5/2 or 2.5. So now from here, what we're going to do is we're going to learn how to use direct and inverse variation in order to solve equations. But to do that, we need to know how to convert a phrase or expression such as z varies directly as h into an equation so that a little later in the lesson we can solve. So when you do this, you take the parts that are given to you where it says z, you just copy down what it says. So z, you write down a z. Varies directly means it's going to be equal to k, and then directly implies that you're going to multiply, and then h comes after the varies directly part. So the equation that we are going to use is going to be z equals k times h. Okay, now if you had z varies inversely as h, you take the z, varies inversely, so it's going to be z equals k. Inversely means divide, so k divided by, and then the h comes next. So z equals k divided by, sorry, that should be an h, not an x. K divided by h. Okay, here's another example. M varies directly as a. So you see the m, so you write an m. Varies means it's going to be equal to k, and then directly is times, and then the letter a. So m equals k times a would be the equation. If it varied inversely as a, it would be k divided by a. Here's another example where x varies inversely as two different things. It varies inversely as y and z. So we see the x, we write an x, and then varies means equals k, and then inversely means divide, and you're dividing by a y and a z. So my equation is going to be x equals k divided by y times z. And here we see a varies inversely as b and c. So same idea, you take a equals, and then k, then divided by b, and then a c as well go in the bottom. Okay, I'm going to go through a couple more to make sure we have this. This one is a little different. We have varies directly as y and inversely as z. So x varies means x equals, and then directly would be k times, and then the y comes next. And inversely means divide. So we divide and then by the z. So x equals k times y over z. Here's another one. A varies inversely as b and directly as c. You see the a, so you write an a. Varies means equals to k. Inversely means divide, so you divide by the b. And directly means you multiply, so you multiply by the c. So my equation would be a equals k times c over b. Now here's another phrase that you need to know, and that is the term jointly proportional, or could be stated as joint variation. When you see the word jointly, all it means is varying directly as more than one quantity. So for example, if you were told z varies jointly as f and c, then the word jointly just means directly. But it's directly proportional to not just f, but also c. So you see the letter z, you write z. Equals, varies would be k, and then jointly is directly, which is multiply. So k times f and c. So k times f and times c. So my equation would be z equals k times f times c. And then one more, z varies jointly as x and the square of y. This one is a little different because we have the square, but same concept. Z, we write the letter z. Varies jointly means directly, so it's going to be multiplying. So equal to k times, and then x, and then the square of y is going to be y squared. So my equation would be z equals k times x times y squared. Now we've been spending a lot of time getting this equation, because once you have the equation, then the solving of different problems will kind of fall into place. So they'll all be kind of similar, and you use this equation to solve. Getting the equation is probably the hardest part for most people. So here's a question. It says if s is directly proportional to t, and s is 20 when t is 15, find t when s is 64. And keep in mind the s and the t can be anything. They're just arbitrary values. Like we said, it could be miles and then gallons of gas. Or it could be whatever, hours worked, and it could be the pay that you earn. So here, we need to first, for each of these, set up our equation. So here we have s is directly proportional to t. So the first part of this is going to be setting up my equation. Well, directly proportional means k times something. So we have k times the t. So my equation would be s equals k times t. And then what I do is I find k given the first set of data. So right here, s is 20 when t is 15. What I do is I plug 20 in for s, 15 in for t, and see what is the relationship between s and t. So I plug a 20 in for s and a 15 in for t. And I solve this for k by dividing both sides by 15. So now I have k equals 20 over 15, which can reduce to give me 4/3. So now I found the relationship between s and t. And now I can find t when s is 64. So what I do is I use the same equation again, s equals k times t. I plug in a 64 in for s. I plug a 4/3 in for k, because that is the relationship. And then I can solve that for t. So here I have 64 equals 4/3 times t. We just need to get rid of the 4/3. Well, we have 4/3 times t, so to get rid of the 4/3, I divide by 4/3, which is the same thing as multiplying by the reciprocal, multiplying by 3/4. So I multiply both sides by 3/4. This 3 3/4 and 4/3 will cancel. 3/4 times 64, or 64 over 1. This can reduce, get 1 over, or 16 over 1. 3 times 16 would be 48. So my solution would be t equals 48. So notice the pattern though. I use the equation. I find k. Once I find k, I plug in k and the other known value to find the unknown value. And that's going to be the same scenario for every question that you get asked like this. So the equation, if you know the equation, which is probably the hardest part, the steps will always be the same as far as solving for the unknown. So here's another example. We have a varies directly as b. So first off, the equation is a equals k times b. And so using that equation, we're told that a is 50 when b is 40. Find a when b is 12. So I plug in scenario 1. A is 50 when b is 40. What is the relationship between 50 and 40? So plug those in for a and b into the equation. Solve for k by dividing both sides by 40. So k would equal 50 over 40, which can reduce to be 5/4. Now I found k. I can use the same equation again. Plug a k in, and then plug a 12 in for b. So I have 5/4 times 12. I can multiply. I get 1 and 3. 3 times 5 is 15. So a would be 15. So I've shown you 2 examples, and I'm going to walk you through a few more with some different types of questions. Where the next one here, we are told that y is directly proportional to the square root of x, and y is 30 when x is 9. Find x when y is 100. So the first thing is we need to set up our equation. Y is directly proportional to x. So directly proportional means it's going to be k times something, and in this case it's going to be k times the square root of x. So plug in what I know to find the k. So y is 30 when x is 9. So plug a 30 for y and a 9 in for x. When I do that, I now have the square root of 9, which is going to be 3. Solve for k by dividing both sides by 3. Now I have k equals 30 over 3, which is going to be 10. So I found k. Now I need to find x when y is 100. So to do that, I use the same equation again. Plug in a 10 for k, plug in a 100 for y, then solve for x. So I get 100 equals 10 times the square root of x. Divide both sides by 10. To solve for x, I get square root of x equals 100 over 10, which is 10. And then to get rid of the square root, I need to do the opposite of square rooting, which is squaring. So I square both sides to get x on the right side, and then 10 squared on the other side. So my answer would be x equals 100. Here's another scenario dealing with actual information, and in this case it's in the context of electronics, where we are told the resistance of a wire. The resistance is measured in ohms, and we're told that it varies directly as the length. So starting with just that, we need an equation. So instead of variables, we're given other information, but we can use variables to represent this actual these actual words. So resistance in ohms, we can let maybe R be resistance, and it says varies directly. So right here, varies directly means equals to k times something, and then it says varies directly as the length. So it'd be R equals k times L. And I guess instead of R, we can just use the symbol for ohms. We can use this instead. Ohm equal k times L. So that's my equation. And then from here, I plug in what I know. So it says a wire 100 centimeters long has a resistance of 10 ohms. So I plug 100 in for the length, 10 in for the ohms, or the resistance, to get 10 equals k times 100. I solve for k by dividing by 100. I get k equals 10 over 100, which is going to be 0.1, or 1/10. So from here, I use the same equation again, plug in 0.1 for k, plug in 14 for the ohms, and then I try to find the length of the wire. So what I have is 14 equals 0.1 times L. Solve for L by dividing both sides by 0.1, and you can use a calculator if you want. But when you do that, you get a length of 140 centimeters, and that is my solution. So when you see a word problem, just use letters to represent what you are trying to find, and then set up your equation once you have that figured out. Here's another example where it deals with varying jointly. So remember, you need to use the equation. Z varies jointly as x and y. Jointly is the same thing as directly, and directly you're going to multiply. So my equation would be z equals k times x times y. And here, same thing. I'm going to plug in what I know. So z is 6 when x is 3 and y is 8. Plug that in to find k. So we have 6 equals k times 3 times 8. 3 times 8 is 24. Solve for k by dividing both sides by 24. So k would equal 6 over 24, which is 1/4. So then from here, I use the equation again a second time. Plug in the 1/4 for k. I plug in a 7 for x. And I plug in a 2 for y. When I do that, I have z equals 1/4 times 7 times 2. So 1/4 times 7 times 2 would be 14 over 4, which can reduce to be 7/2 or 3.5. And that is my solution. Here is one more where z is inversely proportional to r. And z is 32 when r is 2.5. Find r when z is 8. First thing is set up the equation. Z is inversely proportional to r would be z equals k, and then divide because it's inversely, so you're dividing by r. Plug in what I know. Z is 32 when r is 2.5. So plug a 32 in for z, plug a 2.5 in for r, and then solve for k. We solve for k by multiplying both sides by 2.5. And when I do that, I now have k equals 2.5 times 32, which is going to be 80. So then I use the same equation again. Plug in 80 in for k, and then plug in an 8 for z, and use that to find r. So I have 8 equals 80 over r. Solve this for r. And I guess there's two ways to think of this. Maybe the easiest way would be to get r out of the bottom. So to do that, you want to multiply by r. So we have this will cancel on the right side. We have 80 on the right, r times 8 on the left, and then divide both sides by 8. So now we have r equals 80 over 8, which is going to be 10. Now there are other examples I could show you along these same lines, but if you know how to get the equation, then you can solve any of these, because the process is the same every time. You plug in what you know to find the constant, and then once you find the constant, use the same equation a second time, and plug the constant in and your other known value in, and find the unknown value. And that concludes our lesson for today. We will see you next time.